August 12th, 1943. 23,000 feet over the Ruhr Valley. Leutnant Franz Stigler pulls his Messerschmitt BF-109 into a climbing turn. His wingman calls out the target, American bombers, 12 o'clock level. But Stigler isn't looking at the bombers. He's looking at their escorts, 7 aircraft, thick-bodied, radial engines. Republic P-47 Thunderbolts. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The German pilots call them Jug, short for juggernaut. Heavy, they say. Slow to turn, they say. Easy kills if you catch them below 15,000 feet. Stigler has heard the stories from other pilots. The P-47 weighs 7 tons empty. That's 3,000 pounds heavier than a Messerschmitt. Basic physics says a heavier fighter can't turn with a lighter one, can't climb as fast, can't accelerate as quickly. But Stigler has also heard other stories about P-47s absorbing cannon hits and continuing to fly, about American pilots nursing crippled Thunderbolts back to England with half the aircraft shot away. Stories he doesn't quite believe, not yet. He advances the throttle. The Daimler-Benz 605 engine pulls strong at altitude, 1,600 horsepower. The 109 accelerates toward the American formation, range 900 meters, 800, 700. The nose-mounted cannon jiggles slightly as the aircraft cuts through turbulent air. Stigler's gloved hand rests on the control column. Steady, patient. The lead P-47 breaks formation. The pilot has seen them. The Thunderbolt rolls left, pulling into a defensive turn. Stigler follows. His finger finds the trigger. The MG-151 20mm cannon is mounted in the nose. Centerline shot, no deflection needed if he can stay behind the American. The gun sight, reticle, tracks across empty sky, chasing the American fighter. The P-47 tightens its turn. Stigler pulls harder. 4G forces press him into his seat. The 109's wing loading is low, 93 kilograms per square meter. The aircraft turns well at altitude, better than most American fighters, better than the P-47 should be able to turn with its weight. The Messerschmitt was designed for this. Light, agile, deadly in a turning fight. But the Thunderbolt stays in the turn, nose coming around. The American pilot knows what he's doing. Stigler pulls harder. 5 Gs. The stick shakes in his hand. Buffeting. The 109 is approaching its limit. The wings are flexing under load. He eases back slightly. The P-47 continues turning. Impossibly tight. For an aircraft that heavy, the American should be falling out of the sky. Should be bleeding energy. Should be an easy target. Stigler tries a different approach. He rolls out, pulls vertical, uses his altitude advantage. The 109 climbs well, better than the P-47. Everyone says so. German engineering, efficient design. He pulls through the top of the loop, rolls inverted, looks down for the American, expects to see the Thunderbolt below him. Struggling to gain altitude, the P-47 is climbing after him, matching his rate. The big Pratt & Whitney radial engine pulling 2,500 horsepower, more than the Daimler-Benz. The American is gaining altitude, not losing it. The thick fuselage houses a power plant that defies expectations. Stigler had been told American engines were inferior, adequate for bombers but lacking the refinement of German engineering. The evidence contradicts the intelligence briefings. Stigler levels out at 26,000 feet. The P-47 levels out with him, range 400 meters, close enough. He fires. The 20mm cannon barks. Bright tracers streak toward the Thunderbolt, yellow phosphorus trails marking the trajectory. Hits. Stigler sees flashes on the American's wing route, metal peeling back, smoke trailing, grey wisps streaming from impact points. The P-47 doesn't break apart, doesn't catch fire, doesn't fall. The pilot rolls hard right, dives away. Stigler follows. The dive steepens, 350 miles per hour, 400, 450. The 109 starts to buffet, control surfaces shaking. The airframe wasn't designed for sustained high-speed dives. The stick vibrates in Stigler's grip. Warning signs. Stigler pulls out at 18,000 feet. His wingman rejoins. The P-47 is gone. Disappeared into cloud cover below, damaged but flying. Stigler radios his report. 1 P-47 engaged. Probable hit. No kill confirmed. The words taste like failure. Back in the debrief room at Javer Airfield, Stigler describes the engagement. The intelligence officer takes notes, pen scratching across paper. How many hits? 3, maybe 4. What happened to the aircraft? It flew away. Damage? Yes, definitely damaged. Smoke, visible impact points, but it kept flying. The intelligence officer nods. He's heard this before. P-47s are difficult to kill. They absorb damage that would destroy a Messerschmitt or a Focke-Wulf. Some pilots claim the Americans are using armor plate everywhere. Others say it's the radial engine. Big, air-cooled, hard to damage critically. Still others insist it's American industrial quality. Better materials, better construction techniques. But nobody knows for certain. The Luftwaffe has studied crashed P-47s. They've examined wreckage, measured armor thickness, documented construction techniques. Engineers have crawled through demolished airframes, documenting rivet patterns and structural reinforcement. But a crashed aircraft doesn't tell you why aircraft that should crash keep flying. The answer to that question arrives 6 weeks later at Rechlin. Preparing and narrating this story took us a lot of time. So, if you are enjoying it, subscribe to our channel. It means a lot to us. Now, back to the story. September 27th, 1943, a railway flat car rolls through the gates of the C2 Luftwaffe's primary test facility. Secured to the flat car is a Republic P-47D Thunderbolt, mostly intact, damaged but repairable. The recovery team found it in a field near Osnabrück. The pilot had crash-landed after an engagement with German fighters. No fire, no catastrophic structural failure, just an engine that finally quit after taking multiple hits. The American pilot survived. He was captured, walking away from the aircraft, hands raised, no resistance. The interrogation report noted he'd flown the crippled Thunderbolt for 45 minutes before the engine failed. 45 minutes on an engine that had been hit by at least 6 20mm cannon rounds. The interrogator asked how this was possible. The American pilot just shrugged, said the Jurg always brought them home. Hauptmann Klaus Ubben watches as ground crew unload the P-47. He's the senior test pilot at Rechlin, 32 years old, engineering degree from Technical University of Berlin. 6 years, flying. Everything the Luftwaffe captures, Spitfires, Lancasters, P-38s, B-17s. His job is simple. Fly enemy aircraft, document performance, identify weaknesses German pilots can exploit, write reports that might save German lives. The P-47 sits on the tarmac like a beached whale. Broad wings, fat fuselage, that massive radial engine dominating the nose. The aircraft weighs 6,400 kilograms empty. Combat loaded, it tops 7,700 kilograms. That's heavier than some German bombers. The Dornier Do-17, a light bomber, weighs less fully loaded. Ubben walks around the aircraft slowly, deliberately, taking mental notes. The skin is aluminum alloy, 20 gauge in most places, thicker around the cockpit and engine. He counts the damage, 17 holes, most from 20mm cannon fire, 3 from 13mm machine guns. Some holes are clean penetrations, entry and exit wounds. Others show impact craters where armor plates stop the rounds cold. The right wing has a hole you could fit your fist through, jagged edges, torn metal. The left horizontal stabilizer is torn. Fabric control surfaces shredded. The rudder has 3 separate impact points. Each one should have made the aircraft unflyable, should have sent it spinning into the ground, but the primary structure is intact. Spars undamaged. Ribs bent, but not broken. Control cables still connected. Tension maintained. Ubben climbs up to the cockpit, slides back the canopy. The mechanism still works despite the combat damage. The pilot's seat has armor plate behind it, thick steel, 65mm, heavy. That alone weighs 90 kilograms, equivalent to an entire man in protective steel. There's armor plating under the seat, armor protecting the engine from below, armor around the oil tank, armor protecting critical systems from every conceivable angle. The Americans aren't just using a little protective plating. They've armored everything critical. The weight penalty is enormous, but the protection is comprehensive. A German pilot aiming for the cockpit has to penetrate serious steel. A pilot aiming for the engine has to get through multiple layers of protection. Redundancy built into every system. The mechanics spend 3 days repairing the captured P-47. They patch holes, replace damaged control surfaces, scavenge parts from other wrecked American aircraft. The engine is the biggest challenge. The Pratt & Whitney R2800 double wasp, 18 cylinders arranged in 2 rows of 9, 2,000 horsepower at takeoff, 2,500 horsepower with water injection at combat power, a mechanical marvel that outweighs most German engines by hundreds of kilograms. The mechanics drain oil from the engine. It's contaminated, metal shavings suspended in black fluid, evidence of internal damage, catastrophic damage by German standards. They disassemble the engine carefully, document every component, photograph damage, measure tolerances. What they find contradicts everything they expected. 3 cylinders have penetration damage, cannon rounds punched clean through, the cylinder walls are cracked, pistons damaged, connecting rods bent, but the engine has 18 cylinders total. 15 are still functional. The engine kept running because it didn't need all 18 cylinders to produce power. Redundancy, American engineering philosophy. Build it heavy, build it tough, build in backup systems. Accept that combat will damage components and plan accordingly. The Germans build engines for efficiency, minimize weight, maximize performance. Every component optimized. Precision engineering that produces exceptional power-to-weight ratios. But optimization means no margin for damage, no redundancy. One hit in the wrong place, and a Daimler-Benz engine quits. Coolant leak, seized piston, broken crankshaft, immediate failure. The Americans build engines for survival, accept the weight penalty, accept the reduced efficiency, but build something that keeps running, even when damaged, even when 3 cylinders are destroyed, even when oil pressure drops, even when coolant temperature spikes. Keep running until the pilot reaches safety. The mechanics rebuild the engine using undamaged cylinders from wrecked American aircraft. They test-fire it on a ground stand, massive steel frame bolted to concrete. The radial coughs to life. It runs rough at first. Oil pressure fluctuates, but after 30 minutes of warm-up, it smooths out. 1800 RPM. Stable. The chief mechanic reports to Ubben. The aircraft is ready for flight testing. October the 5th, 1943, 08:15 hours. Ubben straps into the P-47's cockpit. The seat is comfortable, more spacious than a Messerschmitt. The Americans build their fighters for larger pilots. Average American height is greater. Average weight is greater. The cockpit accommodates this reality. The instrument panel is laid out logically. Airspeed indicator, altimeter, artificial horizon, engine gauges grouped together on the right side, fuel gauges on the left. Everything is labeled in English. Ubben reads English fluently. Engineering school required it. Technical manuals from Britain and America were essential reading. He locates the essential controls. Throttle on the left side, mixture control below, propeller pitch control, gear lever, flap lever, gun switches safely off. The last thing Recklin needs is an accidental firing of 8 50 caliber machine guns on the ground. Each gun carries hundreds of rounds, enough firepower to shred a hangar. He signals the ground crew. They pull the wheel chocks. Ubben engages the starter. The big radial coughs once, twice, catches. The 18 cylinders fire in sequence. The aircraft shakes. Radial engines always shake more than inline engines. Reciprocating mass, moving in a circle, creates vibration inherent to the design. The Germans prefer inline engines for this reason. Smoother operation, less vibration fatigue on airframe components, but the Americans accept vibration in exchange for ruggedness. Ubben lets the engine warm. Oil temperature climbs slowly. Cylinder head temperature rises. The gauges settle into normal range. Green arcs on American instruments. He tests the magnetos. Both check good. Electrical systems functioning. He advances the throttle slightly. The engine responds smoothly. No hesitation. No missing. No rough running, despite the rebuilt cylinders. Taxiing is straightforward. The P-47 has a steerable tailwheel. Better ground handling than some German fighters. The Messerschmitt 109's tailwheel is not steerable. Requires differential braking and rudder inputs to control direction. The American system is simpler, more forgiving. He rolls to the runway, runs through the pre-takeoff checks, mixture rich, propeller full forward, flaps up, trim set for takeoff, control surfaces free and correct. He advances the throttle. The engine roars, deep, thunderous sound. The Thunderbolt accelerates slowly at first, that weight working against it. 7 tons of aircraft fighting inertia, but as speed builds, the acceleration improves. The tail lifts at 40 miles per hour. At 95 miles per hour, Ubben eases back on the stick. The P-47 lifts off smoothly. No drama, no tendency to swing. Just clean separation from the runway. Gear up. The hydraulic system whines. Electric motors driving hydraulic pumps. The gear doors close with solid clunks. Heavy mechanisms. Robust construction. Oben climbs at 170 miles per hour. The rate of climb is good, better than he expected for such a heavy aircraft, 2,800 feet per minute. The big radial engine pulling hard, the turbo supercharger feeding compressed air to the cylinders. At 5,000 feet, he levels off. Time to evaluate handling. He tries gentle turns. First left, then right. The ailerons are effective. Not as light as a Messerschmitt's controls, but responsive, immediate. Reaction to stick input. The aircraft rolls predictably. No bad habits, no adverse yaw, no tendency to overbank or snap into unusual attitudes. He tries tighter turns. Pull 3 Gs. The P-47 responds well. The turn radius is wider than a 109, but not dramatically so. The wing loading is actually similar. 140 kilograms per square meter for the P-47, 93 for the 109. The difference is noticeable but not crippling. Certainly not the dramatic inferiority German intelligence suggested. Oben pushes the throttle forward, full power. The engine delivers. The turbo supercharger spools up, exhaust-driven turbine spinning at thousands of RPM, compressing intake air, maintaining sea-level pressure at altitude. That's the P-47's secret weapon. A turbo supercharger, driven by exhaust gases, maintains full power at high altitude. The Messerschmitt uses a mechanical supercharger, gear-driven. Works well, but loses efficiency above 20,000 feet. Power falls off, performance degrades. He climbs to 25,000 feet. The P-47 is still accelerating. The turbo supercharger keeps the engine producing power. At this altitude, the Thunderbolt would have an advantage over most German fighters. Better acceleration, better sustained speed. German fighters struggle here. The thin air defeats their mechanical superchargers, but the P-47 thrives. He tests the stall characteristics. Power off, nose up, speed decreasing gradually. The buffet starts at 120 miles per hour. Clear warning. Airframe shaking, controls getting mushy. The stall brakes at 110 miles per hour. Gentle. The nose drops straight ahead. No wing drop, no tendency to spin, no violent brake. He recovers easily. Add power. Lower the nose. The aircraft accelerates smoothly back into controlled flight. He tries the stall with power on. Flaps down. Simulating a landing approach. The stall speed drops to 95 miles per hour. Still gentle. Still predictable. An easy aircraft to fly near its limits. That matters in combat. A pilot can focus on fighting, not on managing the aircraft. The Messerschmitt 109 will snap into a spin if mishandled near the stall. The Focke-Wulf 190 drops a wing violently, but the P-47 just mushes. Forgiving. Predictable. Oben spends 90 minutes testing every aspect of the P-47's performance. Climbs, dives, turns, accelerations. He pushes the aircraft to 460 miles per hour in a dive. The controls get heavier, but remain effective. No dangerous vibration. No control flutter. No structural complaints. The airframe is stressed for high-speed flight, built to handle the forces. When he lands back at Rechlin, the ground crew is waiting. They want his assessment. Oben shuts down the engine. The radial winds down. Pistons stop reciprocating. He climbs out, stands looking at the big American fighter. His initial report will be typed and classified, distributed to Luftwaffe command. Fighter units, intelligence, sections. But his verbal summary is simple. It's better than we thought. Much better. Over the next week, Oben flies the captured P-47 6 more times. He conducts systematic performance testing, maximum speed at various altitudes, rate of climb from sea level to 30,000 feet, fuel consumption at cruise power and combat power, turn performance at different speeds and altitudes, acceleration characteristics, dive recovery, every parameter measured, every capability documented. The data contradicts German assumptions about American fighter design. The P-47 isn't slow. Maximum speed is 428 miles per hour at 28,000 feet. That's faster than most Messerschmitt variants. Faster than the Focke-Wulf 190A. Competitive with the best fighters Germany fields. The climb rate is excellent above 15,000 feet. Below that altitude, the Messerschmitt climbs better. The lighter airframe and lower wing loading give it an advantage. But above 20,000 feet, The P-47's turbo supercharger gives it an advantage. And since most combat over Germany happens at 20,000 feet or higher, that advantage matters. The bombers fly high, the escorts fly high. The battles occur where the P-47 excels. The dive performance is exceptional. The P-47 accelerates in a dive faster than any German fighter, and it remains controllable at speeds that would cause a Messerschmitt to buffet dangerously. American pilots use this. They dive away from trouble. German fighters can't follow without risking structural failure. The control surfaces flutter. The wings flex beyond design limits. Pilots have to back off or risk the aircraft breaking apart. But Ubben's most important discovery isn't about performance numbers. It's about survivability. He examines the aircraft structure carefully, traces where those 17 combat damage holes penetrated, maps out what systems they affected, creates detailed diagrams showing projectile paths through the airframe. Most of the hits missed critical components entirely. The P-47's designers placed essential systems, fuel tanks, hydraulic lines, control cables, deep inside the fuselage, protected by the engine, protected by armor plate, protected by redundant routing. A cannon round has to penetrate multiple layers, has to defeat armor, has to navigate structural members, has to strike a precise location to cause critical damage. One cannon round penetrated the left wing, missed the main spar by 8 centimeters. If it had hit the spar, the wing might have failed, but the spar is thick, heavily built, massive structural member. Even a direct hit might not have been catastrophic. The spar would have been damaged, but might have held together long enough for the pilot to land. 2 rounds hit the fuselage just behind the cockpit, penetrated the skin, rattled around inside, hit nothing vital. The Americans use a semi-monocoque construction. The skin carries some structural load, but the frame provides the primary strength. Holes in the skin don't compromise the airframe. The stringers and formers maintain structural integrity. Their load paths bypass damaged areas. 3 rounds struck the engine area. 1 punched through a cylinder. 1 damaged the supercharger ducting. 1 hit the oil cooler. Any one of those hits should have stopped the engine immediately, should have caused catastrophic failure. Seized pistons, lost oil pressure, overheating. But the engine ran for 45 more minutes because the damage wasn't quite critical enough. The oil cooler leaked slowly, not catastrophically. The cylinder damage reduced power, but didn't stop combustion entirely. 15 cylinders kept firing. The supercharger ducting could be partially bypassed. Pressure was reduced, but not eliminated. Ubben writes in his report, the P-47 demonstrates exceptional damage tolerance. Critical systems are protected by armor, structural mass, and redundant design. The aircraft can sustain multiple combat hits and remain operational. German pilots should not assume visible damage indicates a kill. The P-47 must be completely destroyed, or the pilot must be incapacitated. Anything less, and the aircraft may survive to return to base. The report circulates through Luftwaffe command. Fighter units receive copies, intelligence sections file it, training squadrons incorporate the findings into briefings, but reading a report is different from experiencing reality. German pilots continue engaging P-47s, and they continue discovering that the American fighters are nearly impossible to kill. December 3rd, 1943. Oberleutnant Heinz Knoke engages a formation of P-47s over Oldenburg. Knoke is an experienced pilot. 43 kills, 2 years of combat over France, Britain, Russia. He knows how to aim, knows how to lead a target, knows where to hit for maximum effect. He's studied aircraft structures, understands where fuel tanks are located, where control runs route through airframes, where pilots sit vulnerable behind thin aluminum. He closes to 300 meters, fires a 3-second burst 20mm cannon and 13mm machine guns, combined firepower. The P-47 takes hits all across the fuselage. Knoke sees pieces fly off, smoke trails. The American fighter rolls inverted, dives away, standard evasion. Knoke has seen it before. Knoke follows. The P-47 is diving at over 400 miles per hour. Knoke's Messerschmitt struggles to keep up. The control stick is heavy. The airframe shudders. High-speed buffet. Warning of structural limits. He fires another burst. More hits. The P-47's right wing shows visible damage. torn metal, streaming fluid, fuel or hydraulic fluid, impossible to tell at this distance. But the American keeps flying, levels out at 8,000 feet, heads west toward England, still under control, still powered, engines still running, flight controls still responding. Noke breaks off, his fuel is low. He can't chase the P-47 all the way to the Channel, can't risk running out of fuel over enemy territory. Back at base, Noke reports 2 confirmed hits on a P-47. Probable kill. The intelligence officer records the claim. But 3 days later, reconnaissance photos show the same P-47, identified by its tail number, parked at an English airfield, under repair but salvageable, not destroyed, not even written off, just damaged and being repaired. The pattern repeats across the front. German pilots hit P-47s, see damage, claim kills, then discover later the aircraft made it home. The Americans are repairing aircraft that should be total losses, bringing them back into service. The logistics are staggering. The industrial capacity, overwhelming. At an American 8th Air Force base in England, maintenance crews develop expertise in P-47 repair. They see aircraft return with damage that would be fatal to other fighters. Engine cowlings torn open, wings holed, fuselages riddled. But the underlying structure is intact. The engine still runs. The pilot is unhurt. They've developed systematic procedures, damage assessment, parts requisition, repair sequencing. Technical Sergeant William Morrison supervises repairs on a P-47 that took 32 hits in a single mission. 13 20mm cannon rounds, 19 13mm machine gun rounds. The pilot flew it back to England, landed safely, walked away, climbed down from the cockpit, no injuries, just shaken. Morrison's crew spends 4 days patching holes, replacing damaged skin panels, repairing control cables, testing systems, hydraulics, electrical, flight controls, each system checked, each component verified. On the 5th day, the aircraft is flying again, returned to combat status, the same aircraft the German pilots claimed as a confirmed kill. The Germans noticed this pattern in intelligence reports. American fighter strength isn't decreasing despite heavy combat. German pilots claim 60 P-47s destroyed in a month. But next month, the Americans have more P-47s over Germany, not fewer. The numbers don't add up. Either German pilots are overclaiming kills, always a problem in air combat, or the Americans are repairing aircraft at an impossible rate. Or both. The truth is both. German pilots do overclaim. In the heat of combat, damage looks like destruction, smoke looks like fire. A diving aircraft looks like a kill. The adrenaline, the stress, the brief glimpses, all contribute to honest errors in assessment. But the Americans also are repairing damaged aircraft at rates the Germans can't match. Industrial capacity, spare parts availability, systematic repair procedures, dedicated maintenance personnel. A damaged Messerschmitt might wait weeks for a replacement engine, months for major structural repairs. If the damage is extensive, the airframe is written off, salvaged for parts. The Germans can't afford to tie up hangar space and mechanic hours on lengthy repairs. Resources are limited. Priorities are harsh. The Americans can. They have excess capacity, excess parts, excess mechanics. A damaged P-47 is more valuable as a repaired fighter than as scrap metal. So they repair aircraft the Germans would abandon, return them to combat, keep the squadrons at full strength. By early 1944, the Luftwaffe recognizes the P-47 as a serious threat, not just because of its performance, but because there are so many of them and they're so hard to kill. Every P-47 that survives combat flies again, accumulates more missions, gains more experience. The pilot learns, the crew chief learns, the squadron develops tactics, the aircraft becomes a psychological weapon. German pilots know that shooting at a P-47 might not accomplish anything. The aircraft might absorb the hits, fly home, return the next day. That knowledge affects decision-making. A pilot who knows his target is hard to kill might hesitate, might break off too early, might not press the attack as aggressively. Fear and doubt creep in. January 1944. Luftwaffe intelligence distributes a detailed bulletin about the P-47 Thunderbolt based on examination of captured aircraft, based on combat reports from hundreds of engagements. based on Ubun's test flights at Rechlin, based on interrogations of captured American pilots, based on analysis of gun camera footage. The bulletin describes the aircraft's strengths and weaknesses. It notes the exceptional high-altitude performance, the diving speed, the firepower, 8 50 caliber machine guns total, 4 in each wing, 3,000 rounds combined, enough ammunition for extended combat, the armor protection, the structural durability, the redundant systems. The recommended tactics are specific. Engage P-47s only when you have altitude advantage. Use diving attacks, hit and run. Do not attempt sustained turning fights. The P-47 can turn competitively above 20,000 feet. Do not assume damage equals a kill. Confirm destruction visually before claiming. Watch the aircraft hit the ground or see the pilot bail out. Avoid the engine. Too well protected. Too redundant. Aim for the cockpit if you have a clear shot. Difficult, but effective. Aim for control surfaces. Try to damage the tail. Sever control cables. Make the aircraft unflyable. But above all, do not waste ammunition on non-critical hits. Every round counts. Ammunition is limited. The bulletin concludes with a stark assessment. The P-47 is among the most durable fighter aircraft encountered. Pilots should expect to require multiple attack runs to achieve destruction. That assessment reaches fighter units across Germany. Some pilots take it seriously, study the recommendations, adjust their tactics. Others dismiss it as defeatist, refuse to believe American aircraft are superior in any meaningful way. But the combat results speak clearly. P-47s keep coming, keep surviving, keep winning engagements. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By spring of 1944, the balance has shifted. American fighters aren't just surviving, they're dominating. The Luftwaffe is losing experienced pilots faster than training schools can replace them. Kill ratios favor the Americans. Territory control favors the Americans. Air superiority favors the Americans. And the P-47 Thunderbolt is a major reason why. Not because it's the fastest fighter. The Messerschmitt 109 is faster at some altitudes, not because it turns the tightest. The Focke-Wulf 190 can outturn it in specific conditions, but because it brings pilots home alive, because it absorbs punishment and keeps flying, because American pilots can fight aggressively, knowing their aircraft will protect them. The German test pilots at Rechlin understand this. Ubun flies the captured P-47 23 times over 6 months. Each flight reinforces the same conclusion. The Americans have built a fighter that prioritizes pilot survival over performance optimization. They accepted weight penalties, accepted reduced maneuverability in some flight regimes, but gained an aircraft that pilots trust completely. In March of 1944, Rechlin receives a second captured P-47. This one is in worse condition. Over 200 documented hits, cannon rounds, machine gun rounds, flak fragments. The aircraft crash-landed in France. The pilot survived with minor injuries. The airframe is barely recognizable as a P-47. Twisted metal, torn skin, shattered canopy, but the critical components tell the story. The engine took 19 direct hits, still ran long enough for an emergency landing. The main spar took 4 hits, never failed structurally, never gave way despite enormous stress. The fuel system took 7 hits, never leaked enough to cause fire. Self-sealing tanks worked as designed, contained the damage, prevented catastrophe. The maintenance team at Rechlin spends 3 weeks documenting every single impact point. They create detailed drawings, engineering diagrams, trace the path of projectiles through the airframe, calculate angles of impact, determine penetration depths, calculate the probability of hitting critical systems based on the hit distribution. Their conclusion: the P-47's layout makes critical hits extremely unlikely. You can hit the aircraft dozens of times and never strike anything that will bring it down immediately. The engine is protected from multiple angles, front, sides, below. The pilot is surrounded by armor and structure, thick steel plate, structural members. The fuel tanks are self-sealing and positioned to minimize fire risk. Protected by wing structure, separated from hot engine components. This isn't luck, it's deliberate design. The engineers at Republic Aviation Corporation understood combat reality. Fighters get hit, systems fail, pilots make mistakes, enemies get lucky shots, but if you protect the essential components and build in redundancy, the aircraft survives, the pilot survives, the mission continues. The Germans couldn't match this approach. Their design philosophy emphasized efficiency and performance. Minimize weight, maximize firepower and speed, build aircraft that excel in theoretical performance metrics, test results, specifications on paper. But theoretical performance doesn't keep pilots alive. The Messerschmitt BF-109 is lighter than the P-47, climbs faster at low altitude, turns tighter in some configurations, looks better on paper. But it's fragile. A single cannon hit in the cooling system and the engine seizes within minutes. Coolant boils away, pistons score, catastrophic failure. A hit in the wing spar and the structure fails. The wing folds, the aircraft tumbles from the sky. A fire in the cockpit and the pilot has seconds to bail out. No time, no margin. The Focke-Wulf 190 is better. Air-cooled radial engine, like the P-47, more resistant to damage. No liquid cooling system to fail, but it lacks the comprehensive armor protection, lacks the structural redundancy. A skilled pilot can keep a damaged 190 flying, but it requires skill and luck, both in short supply as the war continues. The P-47 requires less of both. The aircraft does the work of keeping itself alive. The pilot can focus on fighting instead of managing battle damage, can focus on tactics instead of emergency procedures, can focus on survival instead of systems management. By mid-1944, the P-47's reputation is established on both sides. American pilots call it the jug with affection, the aircraft that always brings them home. German pilots call it the jug with respect tinged by frustration, the opponent they can't kill. Nobody mocks it anymore. Nobody claims it's easy to kill. Those who did learned otherwise in combat. The combat statistics prove the point. P-47 loss rates per sortie are lower than any other American fighter in Europe, not because it avoids combat. P-47 units fly aggressive offensive missions deep into Germany, escort missions, fighter sweeps, ground attack, but because the aircraft brings pilots home despite battle damage. First Lieutenant Robert S. Johnson exemplifies this. June 26, 1943, Johnson's P-47 is hit by a Focke-Wulf 190 over France. The German pilot, Oberfeldwebel Egon Meyer, makes multiple attack runs. An experienced fighter pilot, skilled marksman, cannon rounds tear through Johnson's aircraft. Methodical, precise. The canopy is shattered, plexiglass fragments everywhere. The cockpit is riddled, holes in the instrument panel, holes in the seat. Johnson is wounded. Blood everywhere, streaming from cuts, soaking his flight suit, but the P-47 keeps flying. The engine keeps running, all 18 cylinders firing. Johnson manages to evade, dives away, uses the P-47's dive performance, heads for England. Meyer follows, fires again, more hits, more damage. The P-47's tail is shredded, control surfaces damaged, fabric torn away, metal structure exposed, but the primary structure holds. The flight controls still respond. Johnson keeps the aircraft airborne through sheer determination and the P-47's rugged design, trimming against damage, compensating for asymmetric forces. Meyer eventually breaks off, out of ammunition, low on fuel, cannot continue the pursuit. Johnson nurses the crippled Thunderbolt across the English Channel, fighting shock, fighting blood loss, fighting an aircraft that barely responds to inputs, lands at his base. Hard landing, collapsed gear, but he survives. The ground crew counts the damage, 201 bullet and cannon strikes. The aircraft is repairable. Johnson survives, returns to combat after recovery, eventually accumulates 27 kills, becomes one of America's leading aces, all because the P-47 absorbed punishment that would have destroyed any other fighter. This story circulates. German pilots hear about it through intelligence channels, captured documents, interrogations. Some don't believe it. 200 hits. Impossible. Must be American propaganda. Exaggeration. But the photographs exist. The damage assessment reports exist. Allied intelligence documented everything. The aircraft was documented thoroughly before repairs began. Every hit catalogued, every damage system noted. The Germans have to accept reality. The P-47 is genuinely that tough, not through armor alone, not through size alone, but through comprehensive, systematic engineering focused on survivability. Every design choice made with combat damage in mind. June 1944, D-Day, +13. Allied forces are expanding their beachhead in Normandy. Breaking out from the beaches, P-47s fly constant ground attack missions, bombs, rockets, strafing runs against German positions. The aircraft that was designed as a high-altitude escort fighter proves equally effective at low-level strike missions. Hauptmann Josef Priller commands Jagdgeschwader 26, a fighter wing defending northern France. His pilots engage P-47s daily. The combat reports are repetitive. Engaged enemy fighters, scored hits, target escaped. Sometimes they achieve kills, sometimes, but the ratio is terrible. 5 engagements for every confirmed destruction. Priller requests more effective tactics. Luftwaffe command responds with the standard guidance. Aim for critical components. Use cannon fire. Concentrate multiple aircraft on single targets. Overwhelm the defenses. But none of it changes the fundamental problem. The P-47 is built to survive exactly this kind of attack. In July, Priller's unit receives a captured American tactical manual. Intelligence officers translated it, distributed to fighter commanders. The manual describes P-47 emergency procedures. What to do when systems fail, when the engine is damaged, when controls are hit, when hydraulics fail, when electrical systems go offline. The manual assumes damage will occur, provides detailed instructions for flying with degraded systems, how to manage an engine running on 14 cylinders instead of 18, how to fly with partial hydraulic failure, manual gear extension procedures, how to land with damaged flaps, emergency trim procedures. The Americans train for failure, expect it, plan for it. Priller realizes the Americans train their pilots, expecting their aircraft to be hit, expecting to fly home damaged. The Germans train pilots to avoid being hit. 2 completely different philosophies, 2 different approaches to air combat. The American approach accepts that fighters operating over enemy territory will be damaged, prepares for it, builds aircraft that can survive it, trains pilots to handle it, provides detailed procedures. The German approach emphasizes getting hit in the first place. Superior tactics, superior aircraft performance, superior pilot skill. Avoid situations where you take damage. But when German pilots do take damage, and inevitably they do, their aircraft are less forgiving, less survivable. The statistics reflect this. German fighter loss rates climb throughout 1944. American fighter loss rates decline. By August, the P-47 is flying deeper into Germany, escorting bombers to targets the Luftwaffe thought were beyond American fighter range. Munich, Vienna, Berlin. The escorts are mostly P-51 Mustangs now, longer range, better suited for deep penetration missions. But P-47s still fly medium-range escorts, still conduct fighter sweeps, still attack ground targets, still bring pilots home, and they still absorb incredible damage. Lieutenant Colonel Francis Gabreski, leading American ace in Europe, flies P-47s throughout his combat tour. 28 kills, multiple engagements where his aircraft is hit, brings home damaged Thunderbolts repeatedly, each time reinforcing the aircraft's reputation. The pattern holds across hundreds of pilots. The P-47 protects them, allows them to gain experience. Experienced pilots survive longer, score more kills, train newer pilots. The cycle reinforces itself. American pilot expertise grows while German expertise declines. The Germans can't match this. Their experienced pilots are dying. The expert 10, the aces, killed in combat. New pilots arrive with minimal training. 50 hours total flight time, sometimes less, barely enough to take off and land safely. They fly aircraft that demand skill to survive combat damage. They face experienced American pilots in aircraft designed for survival. The mathematics are brutal. The outcome is predictable. German pilot life expectancy drops. By late 1944, a new Luftwaffe fighter pilot has perhaps 10 combat missions before being killed or captured. 10 missions to learn, to survive. To become effective, not enough time. The best German pilots, the Expert 10, with hundreds of kills, are stretched thin, flying multiple missions per day, no rest, no rotation home, fighting until death or capture. Meanwhile, American pilots complete 50 mission tours, rotate stateside, train new pilots, and sometimes return for second tours. The P-47's survivability contributes directly to this. Pilots who might have died in less durable fighters survive, gain experience, become aces. The aircraft's ruggedness translates into pilot expertise. By December of 1944, Oben at Rechlin has flown captured P-47s over 100 hours, more than any other German pilot, more hours than most American P-47 pilots, accumulating combat. He's written multiple detailed reports, compared the P-47 to every German fighter in service, Messerschmitt 109G, Focke-Wulf 190A and D models, even the Me-262 jet fighter. His final assessment is included in a classified technical bulletin distributed to remaining fighter units. The Republic P-47 represents American industrial philosophy applied to fighter design: heavy, rugged, maintainable, survivable. It sacrifices theoretical performance for practical durability. In sustained operations, this approach proves superior. The aircraft returns from missions that would destroy lighter, more optimized designs. Pilots survive to fly again. Experience accumulates. The strategic impact is significant. The bulletin recommends German designers consider survivability more seriously in future aircraft development. But by December 1944, Germany has no future aircraft development. The war is nearly over. Resources are exhausted. Factories are being bombed around the clock. The Me-262 jet offers hope but arrives too late and in too few numbers. The P-47 Thunderbolt continues flying, continues fighting, continues bringing pilots home. In the final months of the war, P-47s transition primarily to ground attack, bombing German positions, strafing vehicle columns, destroying rail infrastructure. The 8 50-caliber machine guns that make it a deadly air-to-air fighter prove equally devastating against ground targets. German soldiers learn to fear the sound of Pratt & Whitney radials. The distinctive roar of P-47s means imminent attack, means rockets and bombs and machine gun fire, means the Americans control the skies completely. No Luftwaffe protection, no air cover, just American fighters prowling at will. March 1945. The Western Allies are crossing the Rhine, pushing deep into Germany. The final offensive, Luftwaffe resistance, is minimal. Most remaining German fighters are grounded. No fuel, no pilots, no spare parts. The infrastructure has collapsed. At Rechlin, the captured P-47 still sits in a hangar. Oben flew it last in February. Since then, fuel shortages have ended all non-essential flight testing. The Americans are approaching from the west, the Soviets from the east. Rechlin will fall soon. The test pilots prepare to evacuate or surrender. Oben writes a final addendum to his P-47 reports. He notes that the aircraft has been in German hands for 18 months, has been flown over 100 hours, has been examined by dozens of engineers and pilots, and the conclusion remains unchanged. The P-47 is the most damage-tolerant fighter aircraft we have evaluated. Its survival in combat stems from comprehensive protective design, redundant systems, and robust construction. German pilots should understand they are facing an opponent that will not succumb easily to battle damage. Multiple hits are required, critical component strikes are difficult to achieve. The aircraft will often escape, despite apparent damage. He doesn't write the obvious conclusion. By March 1945, it doesn't matter what German pilots understand about the P-47. There are too few German pilots left, too few aircraft, too little fuel. The war is ending. The conclusions are academic now. The P-47 Thunderbolt finishes World War II with a remarkable record. Over 15,000 built, hundreds of thousands of combat missions, fighter sweeps, bomber escorts, ground attack. The aircraft excelled at everything, versatile, capable, deadly. More importantly, it brought pilots home. The loss rate per sortie was dramatically lower than comparable fighters, not because it avoided danger. P-47 units flew some of the most dangerous missions of the war, but because the aircraft protected its pilot, absorbed damage, kept flying, gave pilots a chance to survive. Republic Aviation's engineers had made conscious design choices. Accept weight, accept reduced performance in some parameters, but build an aircraft that survives combat. The results validated those choices completely. The P-47 was heavier than ideal, slower to climb at low altitude, but it was the aircraft pilots wanted when heading into combat. Up next, you've got two more standout stories right on your screen. If this one hits the mark, you won't want to pass these up. Just click and check them out, and don't forget to like, subscribe, and turn on the notification bell so you don't miss any upload from us.